Okay, guys, today we're going to talk about proportion and why we are learning ratio. Proportion is a kind of ratio that is included, and sometimes they will ask us, oh, are those things proportional? Oh, what? And you probably heard that proportions. So if you go and let's kind of write this little definition about it, and an equation that shows that two ratios are equal is called proportion. So the two things can be proportional or cannot be proportional. So if they're proportional, they are growing and in the same value proportionally, and if they're not, they are growing in different. Like when you think about if somebody is the same height and then one is growing slowly, other boy is growing very quickly, they are not proportional growth. But if the two boys are 10 years old and they're same height, and then next year they are same, they grow the same height, they can they grow proportionally. So if you look that, we can, instead of the numbers, we can use letters. And remember, sixth grade needs to know variables, and variable could be any number, and variables are letters that we use instead of numbers to show some formulas or something that you can use. So we can read this as A to B proportions. Remember, when we read it, we say A to B is a same as C to D. So that's how we can read a proportion. So I'm going to move this so you can see the title. And then if you needed to take a note, please go ahead and do so. Okay. So A to B is a same as a C to D. Equal sign, we usually in math we're reading a same as. So this side is a same as that side. So A to B is a same as a C to D. So what that means is the proportion in between A and B is going to be same as a proportion in between C and D. We also can see it as a fraction model because ratio is shown. Excuse me, can you mute yourself, Anisha? Can you mute yourself, please? Thank you. We also use the fraction line to show proportions. A to B is the same C to D, or that's another way to show ratios or show proportions. So what I said before, two things can be proportional and not be proportional. That's kind of that you can. So let's explore some numbers. Guys, are there any questions? Are you okay to take notes on this?
I'm not done yet.
Okay, I'll wait a little bit. Okay, so when we talk about, I'm going to move a little bit. So when you talk about proportional, we can look at these two examples. For example, if I have a half, one half is the same as a 4/8. And you know that because you can, you looking, it's the same. Half can, if I cut half in a four small pieces, I can get 4/8, and that is equivalency in a fraction. But it's also, you can see that one. Is there somebody who knows what do I multiply each numerator and denominator to get to the to 4 and 8. What do I do with the numerator? Times what? And times denominator. What do I multiply to get my numbers here? What did I multiply numerator and denominator?
By 4.
By 4. Bravo. So times 4 is equal to 4/8. So that means that the proportion is the same. 1/2 is same as a 4/8, and they are growing proportionally, or they're proportional. Okay. When we think about this 1/2 and 3/8, so if I think this way, I can say, oh, 1 times 3 must be 3, correct? But then I needed to multiply by the same number in order to be my proportions correct, equivalent. Then, but 2 times 3 is not 8. 2 times 3 is 6. So practically this is times 4, and a 3 and 4 are not the same. So they are not growing proportionally. They're not growing by the same number. Does that make sense? Okay, so the why we are learning this is also you can see that as a 1 to 2 proportion is the same as 4 to 8. And then 1 to 2 is not same as a 3 to 8. So 1 and 2 are not proportional to 3 to 8, and 1 to 2 is proportional to 4 and 8. But you also can see, like, if I do now thinking about 4 times 2 is 8. And if I multiply 4 by 2, I'll get 8. If I multiply 8 by 2, I'm going to get what? I can get 16, correct? Because 8 times 2 is 16. So I can see this as 1 to 2 is proportional to 4 to 8, and it's also proportional to 8 to 16. So if I want to find another proportion that is 1 to 2, is the same as 8 to 16. So that's also another number that is proportional to 1/2. 1/2 is, so you can see as 1/2 is proportional to 8/16. So that's the, you can do on as many numbers are. But why do we learn this? Sometimes sixth grade will have problems such as rectangles. So if they have two different rectangles, and then they will ask you, hey, are those rectangles proportional? And then you have to look their values, their length and height, length and width, sorry, and be able to see are they are proportional. So that means the what that means is that two rectangles are similar. They grow in the same proportion. So I drew some of them. So I'm gonna give another way that you can look into it now. Okay, let me just move this. Okay, so write it down. Are these two rectangles similar? They're not the same. They're not congruent, correct? But do they look like similar? If they're similar, that the proportion has to be that they should be proportional. Does that make sense? So like and then what do you look into it is you looking the sides. So let me first, you write these. Okay, the best of your ability, choose and do the take notes, and drew these two rectangles and write the values on next to it. So I'm just going to show you that this will represent the length, and of course this is also linked. So I'm going to compare length to length, and I'm going to compare width to width. Okay, so it's important if things are proportional, that you can really get from 2 to 8. Also, you can get from 3 to 12. And I think some of you already know are these two rectangle proportional. So if you look and we want to write it down, okay, I'm going to give you some time to draw it. Please, and let me know when you're done, or somebody else who is, so I can kind of. Can I move on, guys?
I'm done.
Thank you. Okay, very good. So when we look this picture, we have two rectangles, and they look, one is smaller, one is larger. But then they said, "Oh, are similar or not?" So what do we need to look? We're gonna look their ratio, and then we will make it see if they are proportional. So if I take this would be I can make like to compare the volume of uh, volume of one. This I will call rectangle one, and then rectangle two. So volume of rectangle one, and also length of rectangle one must be equal to the no volume. Sorry, this is width. Apologize. We're learning volume the other day, and then I start keeping saying the length and width of the rectangle one has to be proportional to width and length of rectangle 2. So when we know that, we can do, and we can say, okay, so what that it looks like is a 2. Width of the first rectangle is a 2. The length of the first rectangle is 3. Must be similar to width, that is 8, and the length that is 12. So now when I look those, I'm thinking, okay, is there a number that I can multiply numerator and denominator that can give me the numbers that are big, greater? So is there somebody know how, what
4.
can I multiply? 4, bravo. So I can think that multiply by 4, and 4 is the same. So that tells me right away that these rectangles are similar, because 2 times 4 is 8, and 3 times 4 is 12. So they are growing proportionally, and they are similar rectangles. They also have they trick you. They give you a trick, which it's another way of checking it. When you go in a cross multiply, you have to get the same number. So look, I have here 3, and if I multiply by 8, what is it 3 times 8? 3 times 8. Somebody tell me, what is it 3 times 8?
24.
24. Bravo. So I get 24, correct? And then I'm going to go opposite. I'm going to do now 2 times 12. What is a 2 times 12?
24.
24. So you see, if I go to a cross multiplication, I can check that I can prove my answer. Okay, 2/3 are similar to 8/12 or they're equivalent fractions if they talk about fractions. And then also when they are proportional, they grow proportionally because I can look cross multiplication and they create a same number. So, but the best thing is to look then if they can grow by the same number, that means they are proportional. So I want you to write it down, please. And then we're going to move to the next one. Okay. So if you are done, I'm going to this is kind of like I just made up this one. So I have a meters. So my width is 5 meters and this one is length is 6 meters, and the width of this rectangle is 10 meters, and the length of this is 14 meters. So now I needed to figure it out. Are these similar? So what do I do first? Who can remember? Look at the example of this here. What did I do first? Somebody there, help me out, please. Remember, we can compare the width and length of one, and then width and length of other one. So what should I write first?
5,
Uh-huh.
6,
5/6 must be similar to
8, 10, 14.
and 14. Okay, so now the first thing what do I need to think is, Anilada, is there a number that I can multiply 5 by to get 10?
Yes, 2.
And what? 2. Okay, so I'll do that. And then what do I do next?
You also have to multiply 6 times 2 to get 14. But
Okay, so does this works if I do that?
no.
No, because really 6 times 2 is 12 and 14 is not 12. So practically this is not, it's, so these two are rectangles, but they are not proportional. They're not similar rectangles because they don't grow by the same number. So this is, it's not 2 doesn't work here. While here I have a 4 and I have 4, the first rectangle is similar to the second, and this one is not similar to the next one. Okay, and so can you please write it down? And now I have one little assignment for you. And that's going to be, I'm going to just give you this value that this is width, this is length. Okay. So I would like you to find me the width and the length, and also width and the length. I wanted this. I wanted one that it's similar and no similar. So can you give me some values? Give me some values so then you can create from this. Lanisha, mute yourself, please. Thank you. So what that means is I want you to guess What could be number that you can put a value for width and length that this rectangle will be similar to this? And what values you can put for this one that, and then they won't be similar. So I need you think that I'm gonna give you 5 minutes to come up with the answer. I'm gonna call on somebody to give me so if you look, yes, okay, so 15 to 18, give me something that is similar to it, and then give me the rectangle, then it's not similar to 15 and 18. Okay, so I need a value for if the rectangle is similar to 15 to 18, and then if not. Okay, go ahead. Expectation is that you're working right now on those problems, because I'm gonna call on somebody to tell me the your values. Keep in
I
mind that
got one.
okay, it's okay to try. It's not okay. It doesn't matter if you are correct or not. It's just the best to try.
Easy, I found out one.
Awesome, Manoleta. I can count on you. Anybody else who would try?
I found some.
Is it Vanessa or Bella? Who's talking? Vanessa.
Vanessa.
Bravo. Good job, Vanessa. Okay, I'm gonna wait for some more people. Kevin, Marcus,
Yeah.
Do you have some ideas? What could be?
Mm, no.
Huh?
No.
No? Would you like Anilada to help you out? Anilada, can you explain Kevin how it goes? If I would like to have a similar.
If you would like to have a similar, you can just find out what 15 times 2 is and 18 times 2 is, and then it'll work.
Would be what?
30
Mhm.
and 36.
And 36, correct?
Yes.
Good. Bravo. Excellent. Um, what other Vanessa, can you give me the one that it's not similar? Not similar.
4 and 8.
Uh, for so how I get? Do I multiply by 4 and 8, or what do you? Hmm.
I meant to say 4 and 6.
4 and 6. So if I multiply this by 4 and this by 6, I will get a ratio that it's not proportional with the one. Correct. Okay, let's make a smaller number. So if I do this by 2 and this by 3, that can you help me what to get values? So 15 times 2 equals what? It seemed like it was before here, 30. But what is a 3 times 18? What is 3 times 18? Come on, guys. Count, multiply. What is a 3 times 18?
54.
54. 18, 3 times, yep. Bravo, Vanessa. So this is not 30 to 54 is not similar to 15 to 18. So this is one of the value that you can try. there is also, if I would like to find something, I would like to tell you, as much as you want to make a bigger triangle, like look, this is a greater, so I would make 30 36. Similar to 15 and 18. But I also can think about, if I go in this direction, I can make the values that are smaller. So I can think about what if which number I can divide 15 and 18, the same number, and I will get the same equivalency as well. So Marcus, are you there?
Yes.
Okay, so remember then what is good in ratio? You can go back and forth. In this case, I later found that 15 times 2 equals 30 and 18 times 2 equals 36. But now I want you to think, I can also divide. So what number, same number, that you can divide 15 and 18, and you're gonna get here the values. What number I can divide both by?
3.
Bravo. So tell me, if I divide 15 by 3, what do I get?
5.
Yes. And then 18 by 3, divide into 3 groups.
6. No, 6. No, yeah, 6.
Yes. So look, you just find another similar triangle. So this also can be the value of 5 and 6 centimeters, because look, 15 18 is similar to 30 to 36 rectangle, but is also 15 18 and 30 36 is similar to 5 6, because you can go back and forth. You can multiply or you can divide by the same number, and you're gonna create similar rectangles. This has to do something with like even simplifying fractions, because if you find and simplify, if you have so you can also see how you get the 30 from 30 to 5 sixths. What did I divide 30 and 36 by to get 5 sixths? What is division? Now I'm doing division. You can do multiplication and you can do division. So 30 divide by what equals 5, and 36 divide by what, you get 6. 5 times what equals 30? You go backward. 5,
6.
6. Bravo. And then 6 times what equals 36?
6.
6. So you see that you can, they're both digits. So that's how you find a um, similar rectangles. So you can do division or you can do multiplication. Either way will work. Okay, so maybe now this sounds, but this is the first time you encounter it, and I'm hoping that you're gonna be better with the more practice. Okay, so let's just do very quickly. If I have like 4 12s, okay, so if I want to find that that's a rectangle that is 4 by 12. Okay, if you use centimeters, then I would like to find similar rectangles. I can do multiply by 2, for example, and then I will get what? What do I get? 4 times 2 is
24.
4 times 12 times 2 is 24. You're right. And then 2 times 4 is
8.
8. Bravo. that if I go in this direction with multiplying. But what if I want to go the opposite direction and I'm going to divide now? So what can I divide both by? 4 and 12 to get another one. What can I divide 4 and 12 by? There's two solutions you can do it. Anybody there? Come on, guys. I need to divide 4 and 12 by one same number so I can get a similar rectangle value. I cannot divide in 4 by 3. But I can do 12. So if you do by 3 and a 4, that you won't get. If I divide by 3, it won't get the same. What can I do? Can I divide by 2? Who knows what the division is? If I divide 4 divided into 2 equals what? What time? Yes, what times 2 equals 4? 2 times 2 is 4. And what is 12 divided into 2?
6.
6. Bravo. So I can, that would be the similar rectangle. So this could be a similar rectangle. Also, if I do, like, I can again go one more time, then I will get 1/3. So 1/3 is a same as 2/6, the same as 4/12, the same as, so you got different, the values for the rectangle, but there will be similar rectangles. Okay. Any comments, guys? Anybody? Thank you very much. I hope you're gonna understand that, and then we'll work further with some more. Thanks everybody who participate and work together with us.